Hello, today we will learn about identifying the x and y intercepts of linear equations so that we can move into graphing eventually. But the learning goal for today is being able to simply identify what are the x and y intercepts of an equation. So we're going to be looking at linear equations, and we're going to start studying them and analyzing them to learn this is what the linear equation represents. Remember, everything in math is a picture. So we're going to learn about intercepts. In order for us to do that, the prior knowledge we will need consists of the ability to solve literal equations for a specific variable. So when we go into review mode, if we had an equation that had more than one variable, how do we solve for a specific variable? In the example I've given, 3x plus 2y equals 6, in order to solve for y, we're going to isolate this variable here and get everything else away from it. So we currently identify what's happening to the y. First, it's multiplying by 2, and then we are adding a positive 3x to it. So we undo all of that in the opposite order. First, we're going to undo the adding positive 3x with subtracting 3x on both sides. From the left-hand side, the 3x's cancel, leaving us with just the 2y we had. On the right-hand side, 6 minus 3x. There's nothing we can do with that. It's just 6 minus 3x. Then to continue isolating for y, we divide both sides by 2, and we end up with y equals 6 minus 3x divided by 2. So we need to remember how we solved literal equations. We also need to remember how to solve equations for specific variables, remembering how we undo certain things. So for example, in the equation 3 plus 5x equals 28, how do we solve for x? Undo the 3, subtract 3 from both sides, and then divide by 5. A simple two-step equation, so we get x equals 5. And then we also have to remember the property of substitution. If we were to evaluate 5x plus 3y, if x were to equal 0 and y were to equal 4, we would substitute the 0 for x, the 4 for y, and evaluate. 5 times 0 is 0, 3 times 4 is 12, 0 plus 12 is 12. So those are the elements of prior knowledge that we'll need and we'll use in the section for identifying our intercepts. So we get into learning about linear equations. What indeed is a linear equation? So the vocabulary we deal with, linear equations have either one or two variables, and those variables are in the first power. More specifically in the numerator, but we won't worry about that right now. So a linear equation has one or two variables, and those variables are in the first power. Most commonly, the variables we use are x and y because we use them for graphing. Again, the equations represent pictures. So we look at pictures, or excuse me, we look at equations that represent pictures. For linear equations, they will make pictures of straight lines on a graph. And that is a linear equation. So the study of linear equations means we're looking at equations and figuring out, well, let's know everything we can about them. So we're going to start studying lines. And we start with the concept of intercepts. So I told you in the previous video, when we analyze lines, we're looking at the x-intercept, the y-intercept, and the slope. We've already talked about slope. Now what we'll do is talk about intercepts. So the definition of an intercept is where a line crosses an axis. So if you have the x-axis, the intercept is where the line crosses the x-axis. If you have the y-intercept, the y-intercept is where the line would cross the y-axis. So that is, by definition, the intercepts. So the x-intercept crosses the x-axis, the y-intercept crosses the y-axis. And we have to know that each intercept is actually an ordered pair. This is going to be very helpful for future concepts. Each intercept has an ordered pair. If you look at this example of a line, we have our coordinate plane, and here's our line crossing the y-intercept, or the y-axis is where it crosses the y-intercept is where it crosses the y-axis. The x-intercept is where it crosses the x-axis, and each of those points is an ordered pair. In this case, the x-intercept, where it crosses the x-axis, is the ordered pair -1, -2, -3, 0. The y-intercept is where it crosses the y-axis at 0, +1. So the y-axis, the y-intercept is 0, 1, the x-intercept is -3, 0, and we have to understand that the intercepts represent ordered pairs. So notice something interesting. For the x-intercept is where y equals 0. The y-intercept is where x equals 0. The x-intercept is when the y-coordinate is 0. The y-intercept is where the x-coordinate is 0. That is very handy in studying lines. So, let's take a look at an example. We will identify the x and y-intercept of the following graph. We're going to identify the x and y-intercept of the following graph. Here's our line crossing the coordinate plane. The x-intercept is where it crosses the x-axis, and that is at the ordered pair 1, 2, 3, 0. The y-intercept is where it crosses the y-axis at 0, 2. Now what we're going to do is put that information to good use. What we can do with that information is learn how to find intercepts from equations. We're going to learn how to find intercepts from equations. We can use the concept of an intercept to find out what they are simply by looking at the equation of the line. We're going to learn how to find out where those 2 points on the graph are without even looking at the line. Completely possible to do because we know the concept of an intercept. The x-intercept is when y equals 0. The y-intercept is when x equals 0. Remember that interesting thing that occurs. And so we're going to use that to study lines. So here is an example. We're going to find the x and the y-intercept of the following equation. Here is an equation for us to work with. And what we can do is find the x-intercept and the y-intercept of this equation. Now remember, the x-intercept is found when y equals 0. So the x-intercept is found when y equals 0. So what can we do with this information? Substitute. We can substitute. We can choose to substitute 0 for y in the equation. So we can rewrite the equation 3x plus 5y, but it's no longer y, it's 0 because the x-intercept is when y equals 0 equals 30. So we've substituted 0 for y because that is the concept of the x-intercept. And now what we can do is solve for x. So we have 3x plus 0 equals 30. And then when we have 3x plus 0 equals 30, of course we know 3x equals 30. And then when we divide both sides by 3, x is 10. So what this means is the x-intercept is 10, 0. Remember, x is 10 when y was 0. So the x-intercept is 10, 0. The y-intercept is found the exact same way. So for the y-intercept, the concept of y-intercept is when x equals 0. Remember that concept. The concept of the y-intercept is when x equals 0. So we can substitute 0 for x in our original equation. So instead of saying 3x, we have 3 times 0 plus 5y equals 30. Notice I'm doing a completely different substitution step. We've already substituted the y, now we're going to do a completely different substitution for x. And here we can solve for y. 3 times 0 is, of course, 0. And 0 plus 5y equals 30 leaves us with simply 5y equals 30. And when we divide both sides by 5, y is equal to 6, which is once again ordered pair. X was 0, y is 6. That is an ordered pair. 0, 6. So we have our x-intercept at 10, 0, and our y-intercept at 0, 6. Let's do a second example. We're going to find the x and y-intercepts of the following equation. The x and y-intercepts of 4x minus 3y equals 24. The x-intercept is when y equals 0, so we substitute 4x minus 3, but not 3y. 3 times 0 equals 24. That leaves us simply with 4x equals 24. So what has happened is that when we substitute 0 for y, this whole term gets completely covered up. We can cover up that term, and it leaves us with just 4x equals 24. So you can do a little shortcut with this. Now we can divide both sides by 4. X equals 6. So the ordered pair, 6, 0, is our x-intercept. For the y-intercept, remembering that the y-intercept by definition is when x equals 0, we're going to substitute 0 for x. 4 times 0 minus 3y equals 24. Now when we do this, we have to be very careful of our signs. This is 4 times 0 minus 3y. This minus sign belongs to this 3. So the minus sign must stay with that 3. So when we have 4 times 0, which is 0, we have negative 3y equals 24. And the same can be used for the cover-up shortcut. When we cover up the x term, we're left with negative 3y. Negative 3y equals 24. And then when we divide both sides by negative 3, what we have left is y equals negative 8. Divide both sides by negative 3. So we're left with y equals negative 8. And our ordered pair for the y-intercept, 0 for x, negative 8 for y. That is our ordered pair. So let's do another example for equations that don't always look as neat as these. That was a neat looking equation. This was a neat looking equation. Maybe there's another type of equation that wouldn't look so neat. And of course there is. There are many forms of equations. So we can look at another example. We will find the x and y intercepts of the following equation. Oh no, there's a fraction. But remember, we're looking for the x and y intercepts. The x-intercept is when y equals 0. So if we have an equation that has y by itself, and we'll get into that later, there's way easier ways to work with this. But when y is by itself, we still substitute 0 for y. Instead of saying y equals, we have 0 equals 2/3 x plus 4. So we still substitute 0 for y. We still need to solve for x. So we still have to undo what's happening to the x. What's happening to it? Multiplying by 2 and dividing by 3, then adding 4. So we undo all of those in the backwards order. We undo adding 4 with subtracting 4. And then we have 0 minus 4, which is negative 4, equals 2/3 x. Now we can undo the divided by 3 with a multiply by 3. So we multiply both sides by 3, and we will have negative 12 equals 2x. And now we can divide by 2. So we have negative 6 equals x, or x equals negative 6. And there is our x-intercept. When x is negative 6, y is 0. We have found our x-intercept simply by plugging in 0 for y. Now the y-intercept is found, again, the same way. We're doing the same thing over and over again. The y-intercept is when x equals 0. So we rewrite our original equation, this time with x as 0. So we have our original equation, x is 0. This makes life easy because anything 0 touches is 0. Anything multiplied by 0 is 0. So it just goes away, and all we are left with is 4. So the y-intercept is 4. The x was 0, the y is 4. Isn't that easy? Now you'll notice the original equation is a certain type of equation we get into later, but it's very easy to identify the y-intercept. When x is 0, y is 4, we're going to use this type of equation very frequently throughout the year. So that's how we find the x and y-intercepts when we have two variables in our equation. But now let's end with a couple of shortcuts. What happens when we have trick questions? Trick questions. Now our trick questions are vertical and horizontal lines. They are tricky. So our trick questions are for vertical and horizontal lines. Very tricky beasts, but very useful. So if we find the x and the y-intercept given by this equation, y equals negative 4. To find the x-intercept, make y 0. To find the y-intercept, make x 0. And we're still going to use the same process, but there is no x in the equation. So what's happening here? There is no x, but we have to go with it for now. The x-intercept is when y equals 0. So let's make y 0 and substitute that into the equation. So we have 0 equals negative 4. That should ring a bell. This goes back to solving equations. When we ended equations with this, we knew there was no solution to that particular equation because this doesn't make any sense. Now, another way of saying no solutions, if you remember that, another way of saying no solutions is undefined. So this is another way of saying undefined, which means there is no x-intercept. Remember, all of this is looking for the x-intercept. There is no x-intercept. So what does that mean? It means it doesn't cross the x-axis. It does not cross the x-axis. A line that does not cross the x-axis is a horizontal line, unless it is the x-axis. It does not cross the x-axis. So this line that we're looking at is horizontal. So let's refresh. We had the equation y equals negative 4. We substitute 0 for y. 0 equals negative 4. Doesn't make any sense. That means the x-axis, the x-intercept doesn't exist. There is no x-intercept. It's a horizontal line. So the y-intercept is very easy as well. When x is 0. Once again, our original equation, y equals negative 4. So there is no x to make 0. So y is already by itself. We don't need to substitute because y is already by itself. We have the y-intercept. It's given right here. So the coordinates are 0, -4. So can you picture the line? It's a horizontal line. The y-intercept is 0, -4. You should be able to picture this line. Even better, you should remember what the slope of that line is. Okay, so this is a horizontal line crossing the y-axis at 0, -4. It is a horizontal line crossing the y-axis at 0, -4. Trick question. Here's another tricky question. Find the x and the y-intercept given by this equation, x equals 6. So we start with the x-intercept. Remember, by definition, the x-intercept is when y equals 0. There is no y. And if there is no y, x is already by itself, we have the x-intercept. The x-intercept is at 6, 0. So whatever lines is going to look like crosses the x-axis at 6, 0. Now let's find the y-intercept. So we find the y-intercept is when x equals 0. And once again, our equation is x equals 6. The y-intercept is when x is 0. How's this going to work? Remember, substitute 0 for x. So we substitute 0 for x. We have 0 equals 6. There we go again. What is that? That doesn't make any sense. It's undefined, meaning that there is no y-intercept. And if there is no y-intercept, it does not cross the y-axis. What does the line look like? This is a vertical line. So it doesn't cross the y-axis. It's a vertical line. What can you tell me about the slope of that line? Hopefully you can remember. Slope is undefined. So the x-axis, or the x-intercept, was at 6, 0. There is no y-intercept, so you should picture this, a vertical line crossing the x-axis at 6. Trick questions. So that is how we can study equations using intercepts. Next time we're going to get into slope-intercept form and look to see if we can find slope without using the graph. So thank you for your time.